So in this video, we have the points A, B, C and D form a rhombus, where AC and BD are diagonals. The coordinates of A, B and C are 7, 4, 1, 2 and 3, 8 respectively. Find the coordinates of D. Now, I don't know about you, but if I'm given a question like this, I really want to visualize it. So I'm going to draw myself a diagram, I think. So the diagram you draw doesn't have to be perfectly accurate. It can just be a sketch. I'm going to draw this. I'll try and draw mine so that I've at least thought about kind of how spaced out the points are. Now, we're going up to 3, 8. So if I go up to something like 12, something like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's not too bad, is it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not so good that time, but that'll do. Okay, right. So, first of all, let's plot these points. So A has the coordinates 7, 4. So this word respectively here makes sure that A, B, C are read in this order, A, B, C. Okay? So A has the coordinates 7, 4. So 7, 4, somewhere around there. So this is A, 7, 4. And then we've got B at 1, 2. So 1 along, 2 up. Right, so there's B. So B's at 1, 2. And then C is at 3, 8. So 3 along and 8 up. So around about there. Okay, so that's C. Now in the question, we're told that AC and BD are diagonals. So what that means is that we know that if that's a diagonal, then the diagonal BD must go through AC's centre because it's a rhombus. So we know that somewhere around there is the centre of that line, and if I'd drawn this accurately, then these would have been meeting at right angles. But I can see it's off. It's because I haven't tried to, because my axes aren't quite right. I mean, it doesn't look too bad, but it is a bit off. These should be right angles there. So BD, D's somewhere over here. That's what I'm looking for, somewhere over there. So our job is to figure out the coordinates of D. Now, if I'd drawn it accurately, I'd probably be able to get a good idea about whereabouts it is. So it'll be interesting to see how close I am. Now, there are a couple of different ways of tackling this problem, and I'll go through both of them just so you can see how they work. So the first way is knowing about the rhombus and how the diagonals meet at that midpoint there. If I was to work out the midpoint of A and C, then I could work out how far along and how far up I need to get from B to the midpoint, and then I could do the same thing again to get to D. So let's go about it that way first. So midpoint of AC. So we add together the x coordinates, so 3 plus 7, and then divide it by 2. And then we have the adding together of the y coordinates, 8 plus 4, and dividing by 2. So 3 plus 7 is 10, divided by 2 is 5. 8 plus 4 is 12, divided by 2 is 6. So this point here should have coordinates 5, 6. And, well, it's not too bad on my graph, I guess. So the idea is that if you think about this as going along and up to your midpoint, then I'm going from 1, 2 along to 5, 6. So 1 goes along to 5, so that will be a distance of 4. And then going from 2 up to 6, well, that's another distance of 4. Okay, so I'm actually going 4 along, 4 up. So what I need to do is then go another 4 along and 4 up to get to D. So from 5, 6, I need to go 4 along, so that would be 9, 5 plus 4 is 9, and then from 6 plus 4 is 10. So D will have the coordinates of 9, 10 to create my rhombus. Okay, so this is the rhombus in question. So that side is parallel to that one. This side is parallel to that one. Okay, and so that's my rhombus. So that is one possible way of doing it. An alternative way, which would have meant that I wouldn't have needed to work out the midpoint. So if I just erase that, and I'll erase that one as well to avoid confusion, I'll just erase that bit as well, is to think of this as more kind of like a vector kind of approach. So if you think about how do I get from B to A, so if I think about how do I get from B to A, so I'm bringing in some vectors here, so don't worry if you haven't met vectors yet, but it's an idea. What exactly they do is they tell you how to get from one point to another. So if I want to get from B to A, and I can identify that by putting B then A and this arrow on the top, what I need to do is I need to go from 1 to 7, so I need to go 6 along, and then from 2 to 4, and then 2 up. So 6 along and 2 up. So we write it like this, so 6 along and 2 up. So that's how we get from B to A. So I know that BA is parallel to CD. So to get from C to D, and it's got to have the same length, I need to go 6 along and 2 up. So this has got to be the same as C to D. So if I'm at 3, 8, and I need to go 6 along and 2 up, I need to go 3 plus 6, which is 9, and then 8 plus 2 is 10. And so I go about it that way. You could equally use a vector approach instead, looking at B to C. So B to C is 2 along, so 1 to 3 is 2 along, and then from 2 to 8, 6 up. But because this vector is parallel to this one and they're the same length, that means that this vector has got to be the same as AD. So if you're at A and you want to get to D, you go from 7 and you go 2 along, so 7 plus 2 is 9, and then you're at 4 and you've got to go 4 up, 6 up. So 4 plus 6 gets you to the 10. And so you can either think of it like, essentially we did a vector approach going through the midpoint, because we went 4 along, 4 up, 4 along, 4 up. So it's kind of like the same thing. But you can either go that way, or you can go that way, or you can go that way. Okay? So there's several different approaches that you could employ here.